Thank you, Chiba-san. I'm Yuki Tsunoda of the Electro-Communications. Today, I'd like to talk to you about a card-size energy harvesting electric power sensor for implementing existing electric appliances into HEMS. This is a table of contents. First, I'll talk about our background and motivation. After talking a system overview, I'll explain power signal sensing architecture and energy harvesting architecture. Next is system implementation. At last, I'll present our conclusion. Now, in the world, everyone focuses on the save power because of global warming issue. Then, home energy management system, HEMS, is expected to reduce the power consumption at houses. However, HEMS cannot implement all electric appliances. Therefore, we propose such existing electric appliances implemented into HEMS with power sensor. The power sensor has to measure electric power and send the data. Traditional clamp power sensor is big and cannot each appliance. Furthermore, it needs some battery or source line. It is necessary that proposed power sensor is small and batteryless to implement existing electric appliance into HEMS. By the way, I'm from Tokyo of Japan. Do you know Japan has two kinds of electric frequency? East side uses 50 Hz. West side uses 60 Hz. My university is here, so we experimented in 50 Hz. This is the proposed electric power sensor. This size is same as a credit card, 54 by 85.6 mm. The electrode of the plug penetrates through this slit, and the plug stabilizes this board. This is an outlet shape of Japan. Thickness of this board is 2 mm. This PB Permalloy is a magnetic material with high permeability. We selected the PB Permalloy as a power sensor. A main power sensor is formed by transformer using PB Permalloy core, where 100 turns of coil is rounded. This is a circuit diagram of this sensor. This figure of glue paper has become black, so if you need, please take a picture. I'm sorry. This sensor consists of two circuits. The one is a circuit for power signal. The other is a circuit for energy harvesting. They have the purpose of buffering. This is a PB Permalloy sensor and the output waveform of it. Since the magnetic flux in the PB Permalloy core is saturated, the output waveform is not sine curve. Therefore, we added a 50 Hz resonator with a coil and a capacitor. These are theoretical formulas of the output voltage with resonator and without resonator. With resonator, Vout is 1 divided by square root 2 sum of R2 and RR times CR times MIN. Without resonator, Vout is 2 pi F times MIN. M means mutual inductance. F means frequency of AC source. Then we assign a real value to them. With resonator is 5,000 times MIM. Without resonator, V out is 300 times MIM. As shown from this expression, we can understand that when resonator is attached, the output voltage can be increased. This is the output waveforms of sensor. Because of flux saturation, the waveform is not sine curve, and peak-to-peak voltage is 900 mV. We cannot exactly measure the voltage which corresponds to the power consumption of electric appliance from the non-sine voltage curves. When resonator is attached, the waveform becomes a sine curve, and peak-to-peak voltage can be increased to 2.35 volts. This is the measurement result of the output voltage. We varied power of electric appliance and measured output voltage of a sensor. These are the values resonated. At top is the value which made capacitance small and was resonated at 50 Hz rather than the bottom. This is a measured value using only PB Permalloy without resonator. It can obtain high output voltage with resonators. We can have high sensitivity with resonators even at low power consuming electric appliances. This sensor can detect consumption power from at power of 6 watt. At power of 6 watt, peak-to-peak voltage of 140 mV is obtained. Since PB Permalloy has hysteresis characteristic, output voltage is saturated at high power consuming electric appliances. This result is consistent with a simulation. This card sensor also has a circuit for energy harvesting. The energy is also obtained by electromagnetic induction. The output of the coil is rectified and doubled by 2 diodes to make DC voltage. The rectified charge is stored to the capacitor. Voltage detector detects the voltage of storage capacitor and turns on and off LDO. LDO means low dropout linear regulator. When capacitor voltage reaches 5 volt, turns on LDO. Voltage detector turns on LDO, and LDO supplies 3.3 volt to RFMCU. When the capacitor voltage falls below 4 volt, voltage detector turns off the LDO. During the capacitor voltage is from 5 volt to 4 volt, the RFMCU receives the signal of the sensor by ADC and sends the data to HEMS controller wirelessly. This is a waveform of communication experiment. This green line is the voltage of storage capacitor. This yellow line is the output voltage of LDO. At 1000 watt, capacitor voltage reaches 5 volt for 800 milliseconds. Then RFMCU consumes the energy. Then the capacitor is recharged again for 500 milliseconds. This is a graph of the amount of electric charge of the capacitor. These are the number of the coil of this coil. When the charge required to operate MCU is 1.4 millicoulomb, we can obtain the required charge on the storage capacitor at the appliance power of more 40 watt with 887 tons of coil. This is a picture when sensor connects RF MCU. This is a voltage slider which adjusts power of electric appliances. This transmitter sends a date, and this receiver receives its date. And then monitoring PC shows a graph of power consumption. This is a screenshot of monitoring PC. We can see the data such as this. For this energy harvesting circuit, it can communicate from the power of 40 watt. Capacitor voltage reaches 5 volt for 84 seconds, and recharge again 48 seconds. Okay, at last, I present conclusion of this research. We demonstrated a card-sized electric power sensor. It can measure the power of existing electric appliances down to 6 watt. It harvests energy from power line of operating appliances of 40 watt. This energy makes the RF MCU to transmit the date of power, therefore enabling him to include existing electric appliances. Thank you for kind attention.